Hello and welcome to our CCNA Complete series. Whether you are starting your network career, preparing for Cisco exam, or filling the gaps of what you already know, this series is built for you. Every episode follows the Cisco exam blueprint. In order with the diagrams, packet tracer labs, and everything you need to actually understand what's happening. Today's episode is episode 1. What is a net? We will cover what is a network, why models exist, and the OSI and TCP/IP models. Let's go. So, like I said, today we are going to cover what is a network, the three building blocks of every network, why network model exists, what is an OSI model and how it looks like, what is the TCP/IP model, and what's the difference between OSI and TCP/IP. What is a network? A network is a collection of devices that are connected together so they can communicate and share resources. That could be two computers in the same room sharing a printer. It could be a company with 10 offices connected over private WAN link. Or it could be your phone streaming a video from a server that is thousands of kilometers away. Every network, no matter how large or small, is built from same three components. The three building blocks. In networking, we think about three building blocks. First, end devices, computers, phones, tablets, printers, IP cameras, servers, where data is created and consumed. Second, network devices, switches, routers, firewalls, wireless access points. The CCNA mostly is about this category and how to configure these devices. Third is media, which is copper cable, fiber optics, Wi-Fi radio signals. This is a typical network. On the left, you have end devices, which is a computer and laptops. They connect to a switch which operates at layer 2. The switch connects to a router at layer 3. The router connects out to the internet. And on the other side sits the server the user is trying to reach. The connection between all these devices, the cable, wireless links, that's all media. Why do we need models? The 1980s problem. Back in 1970s and early 80s, every major network vendor had their own proprietary system. IBM had SNA, DEC had DECnet, Novell had IPX, SPX. These systems would work great within their own vendor ecosystem, but they did not talk to each other. If your company ran IBM equipment and needed to connect it with a partner running DEC hardware, you had a serious compatibility problem. As the network grew, this was clearly unsustainable. So the solution, ISO published the OSI model. In 1984, the International Organization for Standardization, that's ISO, published the OSI model. The goal was a vendor-neutral framework that any network technology could map to, a common language for the industry. The key design principle: each layer has a single, well-defined job, and it only interacts with the layers directly above and below it. Practical example, you upgrade your physical cable from a copper to fiber optic, that's layer 1 change, and your IP routing at layer 3 doesn't care. The layers are independent of each other. The OSI model has 7 layers. You need to memorize these layers. I'll go from bottom to top, from hardware up to application. First layer, physical, which cables, fibers, wireless signals, converts data into bits. Layer 2, data link, frames, MAC addresses, Ethernet, switches operates here. Layer 3, network, packets, IP addressing, routing, routers operates here. Layer 4, transport, TCP, reliable connection oriented, and UDP, fast connectionless port numbers. Layer 5, session, sessions, dialog, checkpoints. Layer 6, presentation, SSL TLS encryption, data formatting and encoding. Layer 7, application, HTTP, FTP, DNS, SMTP, the protocols that your application uses directly. OSI layer from 1 to 4, the actual physical medium, which is copper cable, fiber optic, wireless signals, converts data into bits and transmits them. Devices used here, hubs, repeaters, and cables. Layer 2, frames sent between directly connected devices on the same segment, uses MAC addresses. Technology, Ethernet. Devices that operates at this layer are switches. Layer 3, network, gets data from one network to a different network. Logical addressing and routing, protocols, IPv4, IPv6, ICMP, device that operates here, router. And layer 4, transport, end-to-end delivery between applications. TCP, reliable, connection-oriented, flow control. UDP is fast, connectionless. Port numbers live here. And OSI layers from 5 to 7. On layer 5 we have session, establishes and manages and terminates sessions between applications, handles dialog control, who speaks when, and synchronization, which also allows data transfer to a checkpointed and resumed if interrupted. Layer 6, presentation, data formatting, translation, compression, and encryption. SLTLS, the encryption that powers HTTPS, operates at layer 6. Make sure data encoded one way at the sender can be correctly interpreted by the receiver. And layer 7, application, the layer closest to the user, where application protocols live: HTTP, HTTPS, FTP, DNS, SMTP, DHCP, SSH, and Telnet. Your browser, email client, and file transfer tools interact with network at layer 7. OSI model, layers and protocol data units, those are PDUs in short. So like I said again, on physical we have cables and signals, which transmits bits. Data link, we have Ethernet, MAC, which transmits frame. Network, we have IPv4 and 6, which transmits packets. Transport, we have TCP and UDP, where we transmit segments and datagram. And the rest is application, the session, presentation, and application, that all of them only transmit data. So, in order to memorize the OSI model, you have two ways, starting from bottom to top. You have please do not throw sausage pizza away, and the other way around, all people seem to need data processing. Maybe this will help you to remember each layer, what it stands for. So like P is physical, right? Please, so it goes to physical. Do, which data link. Not, network. Throw, transport. Sausage, session. pizza presentation away is application. TCP/IP model, what the internet actually runs on. While OSI model is a theoretical standard, the TCP/IP model is what actually runs on the internet. It was developed by DARPA starting in late 60s, and it predates OSI by more than a decade. Every device connected to the internet today runs TCP/IP stack. So TCP/IP has 4 layers. Application collapse OSI session presentation application layer into one. All application protocol live here: HTTP, HTTPS, FTP, SSH, DNS, and so on. Transport is identical to OSI layer 4, where it sits TCP and UDP. Internet identical to OSI layer 3. IP addressing and routing, IPv6, IPv4, ARP. Network access combines OSI layer 1 and 2, Ethernet, Wi-Fi, and physical cabling. You may also see the bottom layer called the link layer or network interface layer. Same concept, different name. So this is how it's mapped. Like I said, from bottom up. Physical and data link now is network access. Network is internet. Transport remains transport. And the REST session, presentation, and application collapses into one, which is application. So think of OSI as a blueprint. It's the theoretical detailed reference model that's perfect for troubleshooting and discussing networking in a vendor-neutral way. Think of TCP/IP as building. It's actual implementation running on every device connected to the internet. Exam tip: anytime you see questions that reference a layer number, it is referring to OSI model. That's universal shorthand in the industry. So layer 2 is MAC address, which means switches. Layer 3 is IP addresses, which means routers. Exam tip: whenever you see a layer number, it's always referencing to OSI. So like I said, layer 2 is a data link layer, which is MAC address, switches, transmits frames. Layer 3, network layer, IP addresses, routers, which transmits packets. Layer 4, transport layer, TCP and UDP, port numbers, segments. These 3 come up constantly, so know them very well. So, key takeaway: OSI has 7 layers, TCP/IP has 4. You need to know both of them. The mapping OSI layer 7, 6, and 5 collapses into TCP/IP application. OSI layer 4 is transport. OSI layer 3 is internet. OSI layer 2 and 1 is network access. OSI layer number are universal. Whenever you see a layer number in documentation, exam question, or conversation, it always refers to OSI. Layered architecture: one responsibility per layer. Changes at one layer doesn't cascade to other. Like I gave the example in the beginning of the video, if you change from copper cable to fiber optic on layer 3, whereas the IP layer is not affected, we don't care. The IP layer doesn't care about the medium. If you can draw both models from the memory right now and explain what each model does, you're ready for every question about this on the exam. In episode 2, We go deep on OSI layer 1 through 4, physical, data link, network, and transport. You learn exactly what happens at each layer, which device operates there, and you'll get hands-on with Packet Tracer. If this video helped you, please subscribe. Every episode in the series follows the official CCNA blueprint. And yeah, I hope I see you in episode 2. Like I said, please subscribe, leave a comment, leave a like or dislike. It's my first video, so I'm working on the way on my speech. So bear with me. I hope this lesson helped you. See you in the next episode. Bye bye.